So let's start talking about same number, more and less. Now, the first thing that you need to be clear about is that we're going to learn about all of these things in two different ways. What are the two different ways? Well, the first way is going to be one-to-one correspondence, and the second way is going to be counting. Okay, so there are two different ways. Let's start out with one-to-one correspondence. So when I think about one-to-one correspondence, what I'm doing is I'm really thinking about not counting the number of sets, but I'm thinking about whether the number of elements in one set matches the number of elements in the other. So for example, if I am thinking about these two sets A and B, the way I can establish one-to-one correspondence is actually by thinking about that I have these rectangles, and I can take one green line and join it with another green line here. So that's one thing that I could do. So here's the green line that I could join, and then I can have a blue line, and this will correspond to the second one, and then I can have a yellow line which is going to make the correspondence to the third one. So if you think about it, there's a a rectangle here, and the yellow rectangle here. Then you have the blue one right over here, and then you have the green one, right? So I don't know how many there are, but they seem to be the same number, and that's what is important. That without counting, they establish that they're the same number. So now let's talking about these two sets. Clearly, using the same idea of one-to-one correspondence, for example, here you can see that the two sets do not have the same number of elements. Okay. Now, please note that for example, if this is too abstract, remember if we want to go from the concrete to the pictorial to the abstract. So, as a concrete example, you can have two children or two people and three chairs, and you can show them that two children can sit on two chairs, and there's going to be an empty chair, right? So that's one-to-one correspondence for you, and then hopefully it should become clear to children that the number of chairs is not the same as the number of children. The sets are not the same, right? And you may note that I started out with the same objects on the right and on the left. For example, set A has three rectangles and three rectangles on the right. Similarly, set A has two triangles and set B has three triangles. So they're the same objects, so that the child finds it easier to establish this idea of one-to-one correspondence. And it's a great idea to actually physically do one-to-one correspondence by getting children to sit in chairs, or do some or having pens and pen caps, so that you can physically establish this one-to-one correspondence. Now you can play the same game over here um, with the three red rectangles and the three blue triangles, and you can establish this one-to-one correspondence by actually just moving these right over here, and you can see that the one-to-one correspondence is very easy to establish by doing something like this. Now again, please note that I haven't counted yet. I'm trying to establish the same number by just putting things together and establishing this one-to-one correspondence. And similarly, if you want to consider the six blue the six red circles and the four blue stars, you can just move the stars over, and you can show that this is one-to-one correspondence. So the two sets do not have the same number of elements. They're not the same. Okay. Now, up till now, we haven't counted, and we are just trying to learn the idea of whether two sets have the same number of elements without counting. That's the start. Okay. Now we can go back, and we can also start counting. So, for example, we can count the number of elements in a set, and if we count the number of elements in a set, we can see, for example, I'm just going to stick to the lower two sets. So I can say that there are three red rectangles in set A, and there are three blue triangles in set B. And now I want to establish this idea now by counting whether they have the same number of elements. And hopefully, especially if you look at the top set, I just moved down to the bottom sets because there's a lot of clutter on top. But when you look at the top sets, you can see they're identical objects. So when you put these sets together and you count, then each child is getting 3 chocolates, and it should be clear to the child that the two sets have the same number of objects. And now, as we start counting, we can establish that, for example, the way I may try to establish this 4 is more than 6 is that I'd probably try to move these. So now you can start counting. I have 1, 1, 2, 3, 4 red circles. Then I'm going to move the fifth red circle, so it's going to be 5 red circles, and then there's going to be 6 red circles. So it should be clear that 4 red circles is going to be less than 6 red circles. And similarly, as I think about these stars, I'm going to start counting, and I'm going to say 1 blue star, 2 blue stars, 3 blue stars, and 4 blue stars. And clearly, if I were to go on and if I had more blue stars, I'd be able to say that there are 5 blue stars and 6 blue stars, but I don't have them. So that means that 4 blue stars is going to be less than 6 blue stars, and 6 blue stars is the same as 6 red circles, and hence, in this case, set A has more elements than set B. So now you can play the same game with one-to-one correspondence, and the way you show that, for example, one set has more and one set has less is to reinforce this idea that what you can do is you can actually start to just pick up the objects and start moving them next to each other and tell them that if, for example, this is establishing this one-to-one correspondence, and if you want to establish this one-to-one correspondence, so you can draw these green lines right over here. This is establishing the one-to-one correspondence. And since you have these 2 empty red circles, which means that there are more red circles than blue stars. And now if you were to go back and revise the whole thing with this this idea of one-to-one correspondence as well as counting, then we would have gotten this idea across that you can sort of establish whether 2 sets have the same number of elements, or whether whether one set has more or less as compared to another, by either using the idea of one-to-one correspondence or by using the idea of counting. Just to give you the reason why I'm fussing so much about this idea of one-to-one correspondence, this is a very deep idea in modern mathematics, this idea of one-to-one correspondence. Just to give you a sense of what it is, let me take you to a Wikipedia article on cardinality, and you can see right over here on the right that they're talking about one-to-one correspondence and how right in the 20th century, I'll go down this article, and this is George Cantor, who sort of talked about various kinds of infinities and used the idea of one-to-one correspondence to establish some very important facts in fundamental mathematics. So what we are doing right here is sort of establishing this basic idea of how to count without actually counting, and using one-to-one correspondence to establish the size of different sets. Thank you.